There is a chip company you probably haven't heard enough about, and it may have just exposed one of the biggest weaknesses in NVIDIA's entire AI empire. Just 2 weeks ago, Jim Keller, the legendary chip architect behind some of the most important processors in modern technology, stood on a stage and said something that should make NVIDIA very uncomfortable. Whatever NVIDIA does, we'll do the opposite. And this isn't some unknown engineer making a wild prediction. Jim Keller helped create the architecture that brought AMD back from the edge of collapse. He helped lay the foundation for Apple's A-series chips. He worked on Tesla's custom AI silicon for self-driving. And now, for the last 4 years, he's been building something radically different at a company called Tenstorrent, a chip designed around open-source architecture, open-source software, cheap memory, and an entirely different approach to AI computing. And according to third-party, community-tested benchmarks, this architecture can deliver around 350 tokens per second on a massive model like DeepSeek R1, while bringing the operating cost down to roughly $6 per million tokens, compared with around $30 for an NVIDIA-based system with similar performance. That's potentially 5 times cheaper. So here's the obvious question. If Tenstorrent has built an AI chip that can challenge NVIDIA on performance while costing dramatically less to run, why isn't everyone talking about it? Because Tenstorrent isn't simply trying to build a better NVIDIA GPU, it's trying to make the traditional GPU model less necessary. Every time you use ChatGPT, Gemini, Claude, or generate an AI image, data centers are running thousands of processors that consume enormous amounts of electricity, cooling, networking capacity, and hardware investment. NVIDIA sits at the center of that spending, so Jim Keller asked a simple question: why does AI computing have to be so expensive? The answer starts with how GPUs work. Modern GPUs contain hardware schedulers, cache systems, memory controllers, and traffic management systems that constantly decide where data should go and when operations should happen. That's useful for unpredictable workloads, but AI inference is different. AI calculations are often highly predictable, so Keller's team made a radical decision: move more of the intelligence from the hardware into the software. Instead of having the chip constantly decide where data should go, Tenstorrent's compiler can plan much of the data movement before computation even begins. By removing some hardware overhead, more silicon can be dedicated to actual computing. Tenstorrent's architecture uses many relatively independent processing units, each with local memory and instructions. Rather than one giant processor fighting for shared resources, workloads are distributed across smaller units that can operate more independently. And this is where open source becomes important. Tenstorrent uses risc-v-based architecture, while its software stack is designed around open development. Developers can inspect, modify, optimize, and contribute to the software. That's completely different from NVIDIA's CUDA ecosystem, where years of software, libraries, and developer tools have created a massive barrier for competitors. Tenstorrent is taking the opposite approach. Instead of locking developers into a proprietary ecosystem, it wants an open community improving the platform. Then there's memory. Modern AI accelerators often depend on expensive high-bandwidth memory, or HBM. Tenstorrent's Blackhole architecture can instead use standard GDDR6, which is much cheaper but has significantly lower bandwidth. So how can it compete? Again, software. The compiler can predict what data each processing unit will need and prefetch it into local SRAM before the computation requires it. The goal is to reduce the importance of raw memory bandwidth by making sure the right data is already waiting. But there is a limit. When AI models become extremely large, local SRAM can't hold everything. The system eventually has to access slower external memory, and traditional HBM-based designs can regain their advantage. In some workloads, even an NVIDIA RTX 3090 can perform better. Tenstorrent knew this, though, because one chip was never the real product. The real challenge is scaling. Massive AI companies aren't buying one accelerator, they're connecting thousands of them. And when thousands of processors have to communicate, networking becomes another major bottleneck. NVIDIA uses technologies such as NVLink and high-speed networking to solve this, but those systems add cost, heat, and complexity. Tenstorrent's answer is to build high-speed Ethernet directly into the architecture. Its Blackhole chip is designed around roughly 400 gigabytes per second of networking bandwidth. In other words, each chip isn't just a processor, it's also part of the network. And once again, the compiler does the heavy lifting. Instead of thousands of processors constantly negotiating where data should go, the software maps much of that communication in advance. Put 32 Blackhole chips inside a Tenstorrent Galaxy server, and they're designed to work more like one coordinated system than 32 separate processors. Connect 36 of those servers, and you get a cluster with more than 1,000 chips. That's where Tenstorrent's approach gets interesting. It isn't trying to beat NVIDIA with one gigantic processor, it's trying to build a completely different way of scaling AI computing. According to third-party community benchmarks, a large Tenstorrent configuration running DeepSeek R1 can reach around 350 tokens per second. But the bigger story is cost. The claimed operating cost is roughly $6 per million tokens, compared with about $30 for a similar NVIDIA-based system. If those numbers hold at scale, that could mean dramatically lower AI inference costs. So why hasn't NVIDIA been replaced already? The biggest obstacle is software. Tenstorrent says around 90% of Hugging Face models can run out of the box on its hardware. That sounds impressive until you're responsible for the other 10%. A developer might accept compatibility issues, but a hospital, bank, or billion-dollar AI company cannot. Enterprise customers need reliability and certainty, and NVIDIA has a huge advantage here. CUDA has been developed for years, supported by massive libraries, tools, optimizations, and a global developer community. Tenstorrent is still catching up, but its open-source approach could become a major advantage. Instead of relying entirely on one company's engineering team, developers around the world can contribute to the software and improve the ecosystem. Then there's Jim Keller. His track record is extraordinary. He helped create AMD's Zen architecture, which became the foundation of AMD's comeback. He helped shape Apple's high-performance chip architecture, then worked on Tesla's custom silicon for self-driving. And there's a pattern. Keller often builds the foundation, then moves on. But Tenstorrent is different. This time, he isn't simply an architect working for someone else. He's the CEO, building his own company, architecture, and software ecosystem. That doesn't mean Tenstorrent is guaranteed to destroy NVIDIA. The software gap is real, memory limitations exist, and NVIDIA's ecosystem remains incredibly powerful. But Tenstorrent doesn't need to completely replace NVIDIA to change the industry. If it proves that AI inference can run efficiently on open hardware, cheaper memory, distributed processing, and software anyone can improve, it proves something much bigger. NVIDIA's way isn't the only way. Open-source hardware, risc-v, compiler-driven computing, cheaper memory, and distributed networking could create a completely different AI infrastructure model. So maybe NVIDIA's monopoly isn't dead yet. Maybe something more important is happening. The first serious alternative is finally emerging, and if Tenstorrent keeps improving its software, compatibility, and scaling, the AI chip market could look very different in just a few years. Because when the hardware is open, the software is open, and the architecture is fundamentally different. NVIDIA can no longer assume everyone has to play by NVIDIA's rules, and Tenstorrent isn't the only company challenging that dominance. Another company built something NVIDIA apparently wanted badly enough to pay around $20 billion for it. So what did they build, and why was NVIDIA willing to spend $20 billion to get it? Watch this video to find out. And if you enjoyed this deep dive, hit the like button, subscribe, and turn on notifications, because the AI chip war is only getting started.